Hello everybody, today we're going to be talking about two types of waves. We're going to be talking about transverse waves and we're going to be talking about longitudinal waves. Now, the first thing to realize is that the way they move, also known as oscillation, is completely different. Transverse waves, the best way to think about it is imagine that you have a rope. In this rope, okay, you're right here. Okay, you're holding the rope, and this rope goes like this. And then let's say it's at a wall right here. So as you move it up and down, you're gonna notice that it starts to go in this pattern of going down, then up, then down, then up, and it even moves depending on the angle that you're moving it and other things. So, and the way that it moves is that for example, like if you move this down, it would be like this. So the propagation direction, even though they're the same way, like if you're moving them, the way they oscillate, the way that let's assume this is like a string or a wave moves is completely different. A longitudinal wave is kind of like a spring. So imagine that you're extending the spring and then you leave it. It's gonna go back. It's gonna go back and coil and coil and coil. So the direction which you move it is the same direction the wave oscillates in, which is different than the transverse wave. Um, Transverse waves, great examples of them are light waves as well as electromagnetic radiation. For longitudinal waves, these are going to be sound waves mostly, but you can also think about earthquakes. Those are also longitudinal waves. Think about the way they vibrate. They don't go up and down, they go side to side. Now, when you're looking at a wave, there are important definitions that we need to talk about: wavelength, wave cycle, period, amplitude, and time. So, starting off by wavelength, wavelength is the best way to think about it is it's the distance between two crests or two troughs. Now, crest is the peak of a wave, the highest point of a wave, and trough is the lowest point of a wave. So to go from one to the other, that would count as a wavelength. But a wavelength would also be going from here to here. So it depends on how you define it. But it's not gonna change if even from going to troughs to crest or crest to trough. The distance between it and the rest point, which is here, like it's kind of like the zero, the x-axis, that is what we call the amplitude. It's mentioned here too, amplitude. And this basically tells you the amount of distance that it is above the rest point. Wave cycle is to go from one specific point to another specific point. So if I'm going to go back here to this point in another wave, you have to complete the whole cycle. So you have to go up and then down. You might be asking yourself, okay, why wouldn't this be the end of the wave cycle? Well, if you look here, this one's going up while this one's going down. So that doesn't count. It has to be the same point and it's pointing in the same direction. That's what counts as the wave cycle. And this is, as I mentioned, the equilibrium position. And there are important things like period and frequency. Now, periods are basically the number of wavelengths passing a fixed point per second. So you can think about it as the number of cycles per second, while period is the opposite. It's the number of seconds per cycle. To go, how many seconds does it go from here to here? While frequency is how many cycles does it go through every 1 second. Frequency is in the units hertz because it is 1/second. So hertz is equal to inverse of second, while period is, since it is 1/frequency, that means that it is equal to second. That is the units it is in. Now, amplitude is correlated with energy. The higher the amplitude, the more energy a wave has. Intensity is the energy per area per time. And what you need to know is that amplitude is proportional to intensity. Displacement in a wave describes how far a particular point on the wave is from the equilibrium point. So, this, for example, if I was asking you about this distance right here from the equilibrium position to this specific point, that would count as displacement. So, and another thing I need to mention to you is the phase difference. So you can have two waves, and depending on their phase or how like where they are in their cycle, they can work together, together with other waves and become stronger waves, or they can work against each other and become weaker waves. So, for example, if you put two waves that are exactly in phase with each other, so that the trough is with the trough, the peak is with the peak, the bottom with the bottom, they both add up and become longer. So you see, this is the equivalence of like adding them together. But if you do that with waves, where the peak of one is above the downward, the lowest point for a wave, the trough and the crest, then they cancel each other out. Of course, this is because these two waves are equal to each other. But if one was bigger than the other, it would not be zero amplitude. It would be a smaller one than both. It can also be something called partially constructive or partially disruptive. And imagine that, let's say I draw a wave like this. If I draw something like, hold on. Something like this, let's say, where the crest and the trough aren't exactly on top of each other, but at the same time, they're not working together. They don't overlap with each other. And that's where it's partially constructive or partially disruptive. The last thing we're going to be talking about is a traveling wave, and this is a wave that's moving. It has a few new definitions. What you need to know is something called the node and the antinode. Antinode is like the highest peak point, and that means that it is at the amplitude. Node is the point in the equilibrium position. That is what the node is. So it has zero amplitude compared to the antinode. And in this standing wave, it has a fixed boundary, which means that it's going to reflect and invert. So this is, imagine the wave was opposite. So rather than it being up on, let's say, the positive x-axis, here it's the negative. This is a brief overview of waves. There are some formulas, but there are some formulas that would help to know. But overall, this should give you an idea of what to expect with waves.